Hello everybody and welcome to our lesson on section 15F, derivatives of logarithmic functions. Now normally I start off this lesson by asking you to watch this video. I've included a link to this video in your Google Classroom notes, the weekly planner, so please watch this video. And from that, you should see that the derivative of ln x is 1 over x. So if we're taking either, this is true for a logarithm or it's slightly different for it's true for a natural logarithm and slightly different for a logarithm with a different base. But if we're taking the natural logarithm of a composite function, we also have to use the chain rule. So if it's just ln of x, the derivative is 1 over x. But if it's ln of a function of x, then we have to take the derivative of the outside function, which is 1 over f of x, times the derivative of f of x. And that's how we end up with this expression. Now, to find the gradient function, we have a couple of examples. So in this case, I'm going to take the derivative of ln of 2x plus 1. So that's 1 over whatever I'm taking ln of times the derivative of this function, which is 2, and I simplify. For this example, I take the derivative of 3, and I factor out that common factor of 2 and take the derivative of ln x, and then I simplify. In this situation, we need to use the quotient rule. So we're going to take the derivative of the numerator divided by the derivative of the numerator times the denominator as is, minus the derivative of the denominator times the numerator as is, all over the denominator squared. Okay. When I take this derivative, I pull out the factor of 2, and the derivative of root x is 1 over 2 x to the negative 1/2 times the original ln x from the denominator of our function. And the derivative of ln x is 1 over x times 2 root x. Sorry, that's a little hard to read. All over ln x squared. Okay, simplifying a little bit, I can cancel out these factors of 2. And I can simplify this 2 root x over x to give me 2 over root x. That's because this is x to the 1/2 divided by x to the 1. So I can keep my base and subtract the exponents. X to the 1/2 minus 1 gives me x to the negative 1/2, or 2 times 1 over root x. And I can now combine these together as one fraction and multiply by this fraction. You'll also notice that instead of writing this very long vinculum or dividing line here, I'm just going to rewrite this as times 1 over ln x squared. Okay, in these scenarios down here, for ln of x cubed, I can start by applying my log rules first, and we're going to do some more examples of that later on in our next video. But here I can drop the 3, keep the ln x, then taking the derivative of ln x is much simpler. If I didn't do that, I would still get the same answer, but that's just a way to simplify. Okay. Over here, just notice that if I take the derivative of ln x, that's 1 over 10 minus 5x times the derivative of 10 minus 5x, which is negative 5. And when I combine them together, I notice I can common factor out a factor of 5. Canceling those factors, I end up with negative 1 over 2 minus x. Here we have one more example where we need to use the quotient rule, taking the derivative of the numerator times the denominator as is, subtracting the derivative of the denominator times the numerator as is, all over the denominator squared. When I take the derivative of ln of 4x, I get 1 over 4x times the derivative of 4x, which is 4, times the x from the original denominator. And here I get the derivative of x, which is 1 times ln of 4x over x squared. Tidying it up a little bit, I end up with 1 minus ln of 4x over x squared. Continue in the next video. Thank you.